Hello, I am Gopakumar. Welcome to your math tutor. Here we focus on helping you to solve the problems in engineering mathematics in the easiest possible way from an exam point of view. If you are interested in theory, then check out NPTEL. Evaluate integral minus infinity to infinity x square minus x plus 2 by x raised to 4 plus 10x square plus 9 dx. In case of contour integration, generally the most critical aspect of solving the problem is identifying the type of the given question. In this question, we have polynomial in numerator and denominator in the form of f of x by g of x, and the power of denominator is greater than the numerator, and also the limit varies from minus infinity to infinity. So it is the question of type 2. Another important thing to note here is, if the question is of type 2, we consider only above real axis poles. That is, we have to find the residues of only positive poles. Before we go further into the video, let me ask a question. Are you familiar with poles and residues? If the answer to the question is no, then you have to watch the previous videos on Cauchy's residues. Here f of z is z square minus z plus 2 by z raised to 4 plus 10 z square plus 9. On factorizing the denominator, z raised to 4 plus 10 z square plus 9, then f of z becomes z square minus z plus 2 by z square plus 9 into z square plus 1. To factorize z raised to 4 plus 10 z square plus 9, put z square equal to k in equation. Then z raised to 4 plus 10 z square plus 9 reduces to k square plus 10k plus 9. Converting k square plus 10k plus 9 into factors, we get k plus 9 into k plus 1. Replace k with z square, then k plus 9 becomes z square plus 9 and k plus 1 becomes z square plus 1. Z square minus z plus 2 divided by z square plus 9 is z plus 3i into z minus 3i. Z square plus 1 is z plus I into z minus I. Let us equate z square plus 9 equal to 0. Then z square is equal to minus 9. Z is equal to plus or minus root of minus 9. It gives z is equal to plus or minus 3i. That gives the factors z plus 3i into z minus 3i. Let us equate z square plus 1 equal to 0. Then z is equal to plus or minus root of minus 1, which is equal to plus or minus I, which gives the factors z plus I into z minus I. Therefore, here the poles are given by z is equal to 3i, z is equal to minus 3i, z is equal to I, and z is equal to minus I. In type 2, we find the residues of only above real axis poles. Here z is equal to 3i and z is equal to I lies above real axis. To find the residue of z is equal to 3i, use Cauchy's residue formula. Limit z tends to a, z minus a, f of z. Substitute a is equal to 3i in the formula, then limit z tends to 3i, z minus 3i into f of z is z square minus z plus 2 by z minus 3i into z plus 3i into z plus I into z minus I. Cancelling z minus 3i terms and substitute z is equal to 3i in the remaining terms. Z square becomes 3i the whole square. Z becomes 3i whole divided by z plus 3i becomes 3i plus 3i, and z plus I becomes 3i plus I, and z minus I becomes 3i minus I. 3i the whole square is minus 9 minus 3i plus 2 divided by 3i plus 3i becomes 6i. 3i plus I becomes 4i, and 3i minus I becomes 2i. Minus 9 plus 2 is 7 minus 3i divided by 6 into 4 into 2 is 48. I cube is minus I. Taking common factor minus 1 from numerator and denominator and cancelling, which is equal to 7 plus 3i by 48i. To find the residue of z is equal to I, use Cauchy's residue formula. Limit z tends to a, z minus a, f of z. Substitute a is equal to I in the formula. We get limit z tends to I, z minus I, f of z. Limit z tends to I, z minus I, f of z is z square minus z plus 2 by z plus 3i into z minus 3i into z plus I into z minus I. Cancelling z minus I terms and substitute z is equal to I in the remaining terms. Z square becomes I square, and z becomes I plus 2 by z plus 3i becomes I plus 3i, z minus 3i becomes I minus 3i, and z plus I becomes I plus I. I square is minus 1 minus I plus 2 by I plus 3i is 4i, I minus 3i is minus 2i, I plus I is 2i, which is equal to 1 minus I by 16i. By using Cauchy's residue theorem, 2 pi I into sum of residues, then minus infinity to infinity x square minus x plus 2 by x raised to 4 plus 10x square plus 9 dx is equal to 2 pi I into sum of residues r1 plus r2. which is equal to 2 pi I into residue of z equal to 3i is 7 plus 3i by 48, and residue of z is equal to I is 1 minus I by 16i. Taking I common from denominator and also take the LCM of 48 and 16, then we get the LCM as 48. After applying the LCM, we get 7 plus 3i plus 3 minus 3i by 48. 3i minus 3i is 0, and cancelling I terms, two pi by 48 into 7 plus 3 is 10. After simplifying, we get 5 pi by 12. Then minus infinity to infinity, x square minus x plus 2 by x raised to 4 plus 10x square plus 9 dx equal to 5 by 12 pi.